Why modern engines last longer than ever. Imagine buying a car today and driving it for over 200,000 miles without ever rebuilding the engine. A few decades ago, that sounded almost impossible. Engines often wore out much sooner, and major repairs were expected as cars aged. Today, however, it's common to see vehicles with 250,000 or even 300,000 miles still running reliably. So what changed? Did engines suddenly become stronger? Or is there something happening behind the scenes that most drivers never notice? The answer is a combination of engineering, technology, and smarter maintenance. Let's explore why modern engines last longer than ever before. The problem with older engines: to understand today's reliability, we first need to look back. Cars built in the 1960s, 70s, and even the 80s were much simpler than today's vehicles. They relied on carburetors instead of fuel injection, mechanical distributors instead of electronic ignition, and many parts were manufactured with less precision than modern standards. Because of this, engines experienced greater friction, uneven fuel delivery, and inconsistent combustion. Internal components wore out faster, oil broke down more quickly, and overheating was much more common. Even regular maintenance couldn't completely prevent wear because the technology simply wasn't advanced enough. Modern engines solved many of these problems through decades of engineering improvements. Precision manufacturing changed everything. One of the biggest reasons engines last longer is manufacturing accuracy. Today's engine components are produced using computer-controlled CNC machines capable of machining metal with incredible precision. Every piston, crankshaft, cylinder wall, and bearing is manufactured to extremely tight tolerances. This means parts fit together almost perfectly. When components fit precisely, they produce less friction, generate less heat, and experience much less wear over time. Manufacturers also use laser measuring systems and robotic quality inspections to ensure every engine leaving the factory meets strict standards. Even tiny improvements in manufacturing can dramatically increase engine life over hundreds of thousands of miles. Better materials mean stronger engines. Modern engines are built using materials that simply didn't exist decades ago. Engine blocks are lighter yet stronger. Cylinder walls receive advanced coatings that resist wear. Pistons use improved aluminum alloys capable of handling extreme temperatures. Valve components are made from heat-resistant metals that maintain their strength after years of operation. Some engines even use plasma-coated cylinders instead of traditional iron liners, reducing both weight and friction. These stronger materials allow engines to operate under higher pressure while experiencing less long-term damage. Synthetic oil is a game-changer. Perhaps no innovation has contributed more to engine longevity than synthetic motor oil. Traditional oils break down relatively quickly under heat. As oil degrades, it loses its ability to lubricate moving parts effectively. That increases friction, leading to faster wear. Synthetic oils are engineered at the molecular level. They remain stable under extreme temperatures, resist oxidation, flow better during cold starts, and maintain lubrication much longer. Modern additives also prevent sludge buildup, reduce corrosion, and keep engines remarkably clean. Because of these improvements, engine components remain protected, even after thousands of miles of driving. Fuel injection replaced carburetors. Another huge leap came from electronic fuel injection. Older carburetors mixed fuel and air mechanically, but they couldn't adjust precisely for changing driving conditions. Sometimes engines ran too rich. Other times they ran too lean. Both situations caused unnecessary wear. Modern fuel injection systems are controlled by computers. Sensors constantly measure airflow, engine temperature, throttle position, oxygen levels, and many other variables. The engine computer calculates the perfect amount of fuel hundreds of times every second. This precise combustion reduces carbon deposits, lowers temperatures, improves efficiency, and minimizes internal stress. Smarter computers protect the engine. Modern engines are monitored by dozens of sensors working together with sophisticated engine control units. These computers constantly watch critical systems. If temperatures rise too high, adjustments are made instantly. If knocking occurs, ignition timing changes automatically. If fuel quality changes, the engine adapts. Many modern vehicles even reduce engine power temporarily to prevent serious damage. Instead of allowing small problems to become catastrophic failures, the computer often corrects them before the driver notices anything wrong. It's like having a mechanic monitoring the engine every second it's running. Cooling systems are more efficient. Heat is one of an engine's biggest enemies. Excessive temperatures damage oil, warp metal components, and accelerate wear. Today's cooling systems are far more advanced than older designs. Electric cooling fans operate only when needed. High-efficiency water pumps circulate coolant more effectively. Thermostats respond faster to temperature changes. Coolant itself has improved significantly, lasting longer while protecting against corrosion. Some modern engines even use electronically controlled cooling systems that precisely regulate operating temperatures for maximum efficiency and durability. Keeping temperatures stable dramatically extends engine life. Better air filtration keeps dirt out. Engines require enormous amounts of air. Unfortunately, air also contains dust, sand, and microscopic particles that can slowly wear internal components. Modern air filtration systems remove extremely small contaminants before they ever reach the combustion chamber. Improved sealing prevents dirt from bypassing the filter. Many intake systems are also designed to reduce moisture and debris entering the engine. Cleaner air means cleaner combustion and far less internal abrasion over the life of the engine. Improved maintenance makes a difference. Technology isn't the only reason engines last longer. Owners now have better maintenance information than ever before. Dashboard reminders notify drivers when oil changes are due. Diagnostic systems detect problems early. Mechanics can connect scan tools and identify issues before they become expensive repairs. High-quality replacement parts are also easier to find than in previous decades. Following scheduled maintenance has become much simpler, helping engines stay healthy for much longer. Driving habits matter too. Modern driving conditions also contribute to engine longevity. Improved roads reduce stress on vehicles. Automatic transmissions shift more smoothly. Engine management systems prevent over-revving. Cruise control maintains steady speeds on highways. Many vehicles even include automatic start-stop systems designed to reduce unnecessary engine wear during idle. While aggressive driving can still shorten an engine's lifespan, today's vehicles actively help drivers operate more efficiently. Can modern engines really last forever? Not exactly. Even the best engineered engines eventually wear out. Timing chains stretch, seals age, bearings wear, rubber components deteriorate. However, compared to engines built several decades ago, modern power plants routinely last 2 or even 3 times longer with proper care. Many taxi fleets, delivery vehicles, and ride-sharing cars regularly exceed 300,000 miles without requiring complete engine rebuilds. That level of durability would have been remarkable only a generation ago. Modern engines didn't become more reliable because of a single breakthrough too. Their durability is the result of decades of relentless engineering, from precision manufacturing and advanced materials to synthetic lubricants, intelligent engine management, and highly efficient cooling systems. Every innovation, no matter how small, has played a role in extending engine life. Today, with proper maintenance, it's not unusual for an engine to surpass 200,000 miles. It's a reminder that behind every reliable vehicle is years of innovation, quietly transforming one of the world's most important machines.